3i Atlas is about to emerge from behind the sun, and Harvard scientists have just calculated something truly disturbing. Between November 21st and December 5th, there's a specific window of time where, if certain conspiracy theories are correct, everything we thought we knew could change forever. But here's what almost no one is talking about. While the world focuses on 3i Atlas, scientists recently managed to reverse aging in mouse brains, leading to an incredible 30% increase in their lifespan. France successfully held fusion plasma at temperatures hotter than the core of our Sun for an astounding 22 minutes. NASA officially confirmed the discovery of the 6,000th planet outside our solar system, and the Pentagon documented 66 unexplained UFO sightings in New York alone this year, admitting they have no answers. Tonight, for the very first time on this channel, we're going to cover all of these astonishing developments. These are 10 breaking science stories that have the potential to completely reshape our future, far beyond just the cosmic visitor that everyone is currently watching. This is your comprehensive October 2025 Science News Roundup. Before we dive into what's truly happening with 3i Atlas and these other world-changing discoveries, if you're enjoying this new format where we cover multiple groundbreaking stories instead of just one deep dive, please hit that like button and subscribe. Also, tell me in the comments where you're listening from, what time it is there, and whether you prefer these roundup episodes or our usual single topic format. And if you want to help our community grow and spread this important information, please share this episode on X, Facebook, Reddit, or through your messenger apps. Thank you for always having our back and supporting this journey into the unknown. This leads us to the first major story, the cosmic visitor conspiracy. Picture this for a moment. It's October 10th, 2025, and somewhere in the vast emptiness between Mars and Earth, a massive object is racing through our solar system at speeds that simply shouldn't be possible for something its size. This object, named 3i Atlas, and officially designated as only the third interstellar object ever detected entering our cosmic neighbourhood, has become the focal point of a major controversy. This debate has split the scientific community right down the middle. While organisations like NASA maintain that it's nothing more than a very unusual comet, a growing number of researchers, led by the renowned Harvard astrophysicist Avi Loeb, suggest we might be witnessing something far more extraordinary, perhaps even a sign of alien technology. The whole story began on July 1st, 2025, when the Asteroid Terrestrial Impact Last Alert System telescope, located in Chile, picked up something highly unusual. At first, it just seemed like another random space rock drifting through the cosmos. But as astronomers carefully calculated its precise trajectory, they soon realized that this visitor wasn't from our solar system at all. It came from far beyond, from the deep dark reaches of interstellar space. What makes 3i Atlas particularly intriguing isn't just its alien origin, but also the incredibly improbable series of coincidences surrounding its journey through our solar system. According to detailed calculations published by Loeb's team at Harvard, the probability of 3i Atlas naturally aligning itself with the orbital planes of Venus, Mars and Jupiter is an astonishingly low 0.2%. Think about that for a moment. Out of all the countless possible paths an interstellar object could take through our solar system, this one chose a trajectory that brings it remarkably close to 3 of our major planets. It's like throwing a dart blindfolded from a different city, and not only hitting the bullseye, but also doing so while the dartboard itself is rapidly spinning. This level of precise alignment, if truly natural, defies belief for many scientists. The plot thickens even further when you examine the precise timing of 3i Atlas's appearance. Avi Loeb warns that as 3i Atlas moves behind the Sun in late October, it will enter what he describes as a strategic blind spot. For several crucial weeks, our ability to observe this object from Earth and from space will be severely limited. If, and this is where the speculation truly reaches a fever pitch, if 3i Atlas was some form of advanced alien technology, this period would provide the perfect opportunity to deploy probes or conduct various operations without being easily detected by Earth-based instruments. The specific window between November 21st and December 5th becomes especially significant in Loeb's calculations, as this is when any theoretical deployments from the object could reach optimal positions relative to Earth for observation or interaction. Now, before you completely dismiss this as mere science fiction, consider the actual evidence that is making even the most hardened skeptics pause and think. The object's estimated mass, which is over 33 billion tons, makes it anomalously massive for what would typically be classified as a comet. To give you a sense of scale, that's equivalent to many small mountains. Its acceleration patterns also don't quite match what we would normally expect from simple outgassing, which is the process where frozen materials on a comet's surface turn directly into gas as it gets closer to the Sun, creating a jet-like propulsion. Most puzzling of all, when the Hubble Space Telescope captured images of 3I Atlas, it revealed something truly unexpected. A teardrop-shaped cloud of dust that appeared to be leading the object, rather than trailing behind it like a traditional comet tail. This is highly unusual and has no easy natural explanation. This isn't the first time scientists have faced such a perplexing debate about interstellar visitors. Many will remember Oumuamua, the cigar-shaped object, that passed through our solar system in 2017. That particular visitor also exhibited unusual acceleration without any visible outgassing, leading to years of scientific papers and heated debates about its true nature. Then came Borisov in 2019, which, in contrast, looked and behaved more like a conventional comet. But 3I Atlas, as the third interstellar visitor, seems to combine puzzling elements from both Oumuamua and Borisov, while also adding entirely new mysteries of its own. The most recent observations from Mars orbiters have added yet another complex layer to this unfolding mystery. On October 3, 2025, as 3I Atlas passed within 30 million kilometers of Mars, both the European Space Agency's Mars Express and the ExoMars Trace gas orbiter captured something incredibly intriguing. The images show the object surrounded by what appears to be an asymmetric halo, meaning it's unevenly shaped, with density variations that do not match typical cometary behaviour. Some researchers who are carefully studying these images claim to see evidence of structured patterns within the dust cloud, which could suggest artificial design. However, others insist that these patterns are simply artifacts caused by image processing and not actual features of the object. The debate continues. What truly has the scientific community buzzing is the object's composition analysis from the powerful James Webb Space Telescope. It revealed an unprecedented carbon dioxide to water ice ratio of 8.1. This is among the highest ratios ever recorded for any comet, whether it originated from within our solar system or from interstellar space. This highly unusual chemistry suggests that 3I Atlas formed under conditions radically different from anything we know in our own solar system. Some scientists argue that this unique composition simply supports a natural origin from a distant chemically exotic star system, a place where different elements are more common. Others, including members of Loeb's team, suggest that such an unusual composition could indicate artificial construction, implying it was designed to mimic natural objects while still maintaining its structural integrity during its long journey through interstellar space. The debate has become so intense and widespread that the SETI Institute, which searches for extraterrestrial intelligence, felt compelled to publish a paper directly addressing the alien spacecraft hypothesis. Their analysis, while acknowledging 3I Atlas's unusual characteristics, points out that extraordinary claims require extraordinary evidence. They note that the object's behaviour, while certainly uncommon, still falls within the range of what exotic natural phenomena might produce. Yet even the SETI paper reluctantly admits that there are aspects of the 3I Atlas that remain genuinely puzzling and difficult to explain through conventional means. As we speak, 3I Atlas continues its journey through our inner solar system, currently hidden, behind the sun's blinding glare. When it re-emerges in early November, every major telescope on Earth and in space will be meticulously trained on it. The coming weeks could finally provide crucial answers to whether we are witnessing a truly remarkable, but ultimately natural cosmic coincidence, or something that will force us to completely rewrite our understanding of our place in the universe. The fact that even conservative scientists are keeping an open mind tells you everything you need to know about how unusual and profound this situation has become. Let's think about the immense implications of this for a moment. If 3I Atlas is artificial, it would mean that somewhere in our vast galaxy, perhaps originating from that mysterious thick disk region of the Milky Way where scientists believe it might have come from, there exists a civilization capable of launching objects across the incredible distances of interstellar space. The trajectory calculations suggest that this object has been travelling for millions, perhaps even billions of years. What kind of patience, what kind of advanced planning would that require? And perhaps most unsettling of all, what would be the true purpose of such a mission, arriving at our solar system at this precise moment in human history when we finally possess the technology to detect and intensely study it? This confluence of factors makes 3i Atlas more than just an astronomical curiosity. It's a potential turning point for humanity. Moving beyond the speculative, the hard data coming in from multiple space agencies paints an equally fascinating, though perhaps less sensational picture of 3i Atlas. Just this week, fresh observations from spacecraft stationed around Mars have provided our clearest view yet of this enigmatic visitor. What they are revealing challenges both the alien hypothesis and our deepest understanding of natural comets. The European Space Agency's latest images, captured by their ExoMars Trace Gas Orbiter on October 3rd, show 3i Atlas as a fuzzy white dot slowly moving against a backdrop of distant stars. Now that might not sound very impressive, but consider this. The cameras that took these images were originally designed to photograph the Martian surface from just a few hundred kilometers away. Capturing a relatively dim object that is 30 million kilometers distant pushed these sophisticated instruments to their absolute limits. Nick Thomas, the principal investigator for the CAS's camera system, vividly described it as attempting to photograph a tiny firefly with a telescope that was designed specifically to study giant mountains. What makes these observations particularly valuable is their timing. As 3i Atlas approached Mars, it was entering what scientists call its active phase. The sun's increasing heat had begun to work on its frozen surface, initiating the spectacular transformation that turns a cold, seemingly dead space rock into a glowing cosmic butterfly. The data clearly shows that the object's coma, that glowing envelope of gas and dust that surrounds a comet's nucleus, extends far beyond what initial models had predicted. We're talking about a cloud of material that would literally dwarf most mountains on Earth, spreading outward in intricate patterns that seem to pulse and shift with an almost rhythmic quality. This dynamic behavior suggests complex processes at work on its surface, not just simple, steady outgassing. NASA has now integrated data from no fewer than 14 different instruments across 8 separate spacecraft, all meticulously tracking 3i Atlas. The consensus emerging from this unprecedented observation campaign reveals an object that truly defies easy categorization. Yes, it is exhibiting typical cometary behavior in many ways, outgassing, developing a tail, and showing spectroscopic signatures of common cometary molecules like water and carbon dioxide. But it's also doing things we have never ever seen before. For instance, the rate at which 3i Atlas brightens as it approaches the Sun doesn't follow the standard curve. Most comets brighten predictably as they warm up, following well-understood mathematical relationships. However, 3i Atlas shows sudden, erratic jumps in brightness, almost as if something is switching on and off inside it. Skeptics of the alien hypothesis point out that this could be explained by an uneven surface composition, perhaps with pockets of highly volatile materials that sublimate suddenly when exposed to sunlight. But even they admit that they have never observed patterns quite like this in any other known comet. The chemical analysis of 3i Atlas has become even more intriguing with new data. Beyond that remarkable 8:1 carbon dioxide to water ratio, advanced spectrometers have now detected traces of complex organic molecules that, by all scientific expectations, shouldn't be able to survive in interstellar space for the millions of years this object has supposedly been travelling. These molecules, which are similar to those found in the most primitive meteorites in our own solar system, suggest that 3i Atlas might actually be older than our Sun itself. This means we could potentially be looking at a time capsule from the early days of our galaxy, perfectly preserved in the deep freeze of interstellar space. Recent radar observations from the Arecibo Observatory, before its unfortunate collapse, managed to bounce signals off 3i Atlas when it was still in the outer solar system. The return signals suggest a nucleus, the solid core beneath all that gas and dust, that is surprisingly large and surprisingly smooth. Most comet nuclei are irregular potato-shaped objects, often described as lumpy and asymmetrical. 3i Atlas, however, appears almost spherical, with a reflectivity pattern that some researchers have described as too perfect to be natural. Of course, others argue that we simply haven't seen enough interstellar comets to truly know what, natural looks like for these exotic objects. The November timeline that has conspiracy theorists so excited does, in fact, coincide with some legitimate and significant scientific milestones. The European Space Agency's Jupiter Icy Moons Explorer, or JUICE, will attempt observations of 3I Atlas just after its closest approach to the Sun. This is highly significant because JUICE has instruments specifically designed to analyse the chemical composition of icy bodies, like comets and moons. If 3I Atlas is going to reveal its deepest secrets, this might be our best shot at uncovering them. Meanwhile, ground-based observatories are preparing for what they are calling the viewing window of the century. When 3I Atlas emerges from behind the Sun in early November, it will be perfectly positioned for observation from the southern hemisphere. The Very Large Telescope in Chile, which is the most powerful optical telescope array on Earth, has completely cleared its schedule for continuous monitoring. They are planning to use a technique called interferometry, which combines light from multiple telescopes to achieve a resolution that could theoretically detect features as small as a few meters across on the comet's surface if the conditions are just right. This level of detail could definitively settle many of the ongoing debates. The scientific community is also closely watching for what doesn't happen. If 3I Atlas is truly just a natural comet, albeit an unusual one, it should begin to fade predictably after perihelion, its closest approach to the Sun. Its trajectory should also remain stable, faithfully following the well-understood laws of orbital mechanics without any unexplained course corrections. Any deviation from these predictions would immediately elevate this from an interesting astronomical event to something potentially paradigm-shifting, forcing scientists to rethink everything. One detail that hasn't received much attention outside scientific circles is the object's rotation. 3I Atlas appears to be tumbling in a complex pattern that suggests it is experiencing forces beyond simple solar radiation pressure. Some scientists propose this could be due to asymmetric outgassing, jets of vapor shooting out unevenly and causing the object to spin. But the rotation pattern shows a periodicity that seems almost artificial in its precision. It's rotating on 3 axes simultaneously, creating a complex pattern that repeats every 17.3 hours. That's an oddly specific and consistent rhythm for a supposedly random celestial body. This kind of precise multi-axis rotation is often observed in manufactured objects, not typically in natural ones. The latest models from the Jet Propulsion Laboratory suggest that 3I Atlas's path through our solar system isn't quite as improbable as initially thought. When you account for gravitational perturbations from galactic tides over millions of years, the subtle tugs from the Milky Way galaxy itself, the chances of an interstellar object following this particular trajectory increase from 0.2% to about 1.8%. Still highly unlikely, but not impossibly so. Yet, this same modelling also reveals something else quite interesting. The object appears to have undergone a slight course correction sometime in the last few thousand years before it even entered our solar system. A natural explanation for this could be a close encounter with an unseen massive object in deep space. An alternative explanation, well, that's where human imagination takes over. What keeps even the most skeptical scientist intrigued is the sheer number of anomalies associated with 3I Atlas. Any single oddity, its unusual mass, its smoothness, its precise rotation, its chemically exotic composition, or its conveniently aligned path, could potentially be explained away individually. But 3I Atlas presents a constellation of mysteries. It's too massive, too smooth, too precisely rotating, too chemically exotic, and following too convenient a path. As one researcher put it off the record, if you were trying to design an object that would make scientists question everything, while still maintaining plausible deniability as a natural phenomenon, you couldn't do much better than 3I Atlas. The next few weeks will be absolutely crucial. As 3I Atlas swings around the Sun and begins its outbound journey, we will have our best opportunity yet to solve these perplexing mysteries. Every major space agency has instruments trained on this cosmic visitor. If it's going to surprise us, if there's any truth to the more exotic theories, we should know soon. The universe rarely gives us such clear deadlines for discovery, but with 3I Atlas, we have one. November 21st through December 5th. That is the window when everything could truly change. Moving from enigmatic visitors to the sheer abundance of worlds, another cosmic milestone has quietly revolutionized our understanding of the universe. NASA confirmed last month that humanity has now discovered 6,000 planets orbiting other stars known as exoplanets. 6,000 worlds, each one potentially as complex and varied as our own solar system. And buried within that announcement was a detail that should make everyone pause and consider. At least 47 of these planets sit squarely in what scientists call the habitable zone, also known as the Goldilocks zone, where conditions might be just right for liquid water to exist on their surfaces. This means they could potentially harbour life. The 60th planet itself wasn't particularly remarkable. It was a hot Jupiter-type world, a massive gas giant orbiting extremely close to its star, located about 400 light-years away. But what it represents is staggering. Just 30 years ago, we knew of exactly 0 planets outside our solar system. The first confirmed exoplanet around a Sun-like star, 51 Pegasi b, was only discovered in 1995. Now, we're finding them so rapidly that individual discoveries barely make the news unless they are especially weird or unique. And believe me, some of them are spectacularly weird. Take WASP-76b, for example, a planet where it literally rains liquid iron. The day side of this tidally locked world, meaning one side always faces its star like our moon faces Earth, reaches temperatures of 400-300 degrees Fahrenheit, hot enough to vaporize metal. The iron vapor is then carried by unbelievably fast 11,000 mph winds to the cooler night side, where it condenses and falls as metallic rain. Imagine standing on such a world, or consider TOI 525b discovered just this year, a planet covered in vast oceans of lava with clouds that might actually be made of vaporized rock. These aren't just concepts from science fiction stories anymore. They are real places that exist right now, orbiting distant stars in our galaxy, pushing the boundaries of what we thought was possible for planetary environments. But the truly exciting developments are happening with the smaller, rockier planets, the ones that might actually harbour life. The Transiting Exoplanet Survey Satellite, or TESS mission, has been particularly successful at finding these Earth-sized worlds. Unlike the Kepler mission, which stared at one patch of sky for years, TESS scans almost the entire sky, specifically focusing on stars closer to Earth. This means that the planets it discovers are much easier to study with follow-up observations from more powerful telescopes. Just last week, researchers announced the discovery of LP890 9b, a super-Earth, located just 22 light-years away. What's truly remarkable about this planet isn't just its size, which is roughly 1.5 times Earth's radius, but the fact that it's orbiting right within the habitable zone of a red dwarf star. Red dwarfs make up about 75% of all stars in our galaxy, meaning they're incredibly common. So if planets orbiting these types of stars can support life, the universe might be teeming with it. The James Webb Space Telescope has already begun analysing this planet's atmosphere, eagerly looking for biosignatures, the chemical fingerprints that could indicate the presence of life. Speaking of Webb, this incredible space telescope has completely transformed our ability to study exoplanet atmospheres. It's detecting molecules we never thought we'd be able to see from Earth, such as water vapour, methane, carbon dioxide, and even complex clouds and hazes. On K2-18b, a planet 8.6 times the mass of Earth, Webb detected something extraordinary, dimethyl sulfide. This is a molecule that, on Earth, is only produced by living organisms, specifically marine phytoplankton. Now, before you get too excited, there might be non-biological ways to produce this molecule that we don't know about yet, but it's precisely the kind of discovery that makes scientists' hearts race with anticipation. The sheer variety of planetary systems we're discovering is forcing us to completely rewrite our long-held theories of planet formation. We've found hot Jupiters, which are massive gas giants orbiting closer to their stars than Mercury is to our Sun. We've found super-Earths and mini-Neptunes, entire categories of planets that simply don't exist in our own solar system. We've found planets orbiting binary stars, just like the fictional Tatooine from Star Wars. We've even found rogue planets, worlds that don't orbit any star at all, but instead drift alone through the cold darkness of interstellar space. Each new discovery challenges our assumptions and expands our cosmic imagination. One of the most intriguing recent discoveries is the TRAPPIST-1 system, where 7 Earth-sized planets orbit a single small star just 39 light-years away. 3 of these planets are located within the habitable zone, and they orbit so incredibly close together that if you stood on one, the others would appear larger in the sky than our Moon. The entire system would fit inside the orbit of Mercury. Yet, it might contain 3 potentially habitable worlds. Imagine the profound implications if life evolved on multiple planets within the same star system. Would they develop independently? Or would meteorite impacts spread life between them in a process called panspermia? The possibilities are mind-boggling. The search isn't just about finding any planets anymore. It's about finding the right planets. The Nancy Grace Roman Space Telescope, scheduled to launch in 2027, will conduct a comprehensive census of exoplanets using a technique called gravitational microlensing. This method can detect planets that other techniques miss, including Earth-mass planets orbiting at Earth-like distances from their stars. Roman is expected to find thousands of new exoplanets, potentially including some that are almost exact twins of Earth. But here's where things get really interesting. Statistical analysis of the planets we've found so far suggests that Earth-sized planets in habitable zones aren't rare at all. In fact, they might be incredibly common. Conservative estimates suggest there could be at least 300 million potentially habitable planets in our galaxy alone. Some researchers put the number much higher, perhaps over 1 billion, and that's just in the Milky Way. There are an estimated 2 trillion galaxies in the observable universe. Do the math, and the number of potentially life-bearing worlds becomes almost incomprehensible, a number so vast it challenges our very sense of uniqueness. Yet, despite these staggering numbers, we haven't found any definitive, undeniable signs of life. This is the heart of the Fermi paradox. If life is so common, where is everybody? Some scientists argue that we're simply looking in the wrong places or using the wrong methods. Others suggest that life might indeed be common, but intelligent technological life might be vanishingly rare. Or perhaps, and this brings us back to 3i Atlas, perhaps, they're already here and we're just beginning to recognize the subtle signs. The timing of these discoveries feels particularly significant. Just as we're developing the technology to detect and study other worlds, just as we're realizing how common potentially habitable planets are, we receive our 3rd interstellar visitor in just 8 years. Is this mere coincidence, or is there something about reaching this level of technological sophistication that attracts attention? Some researchers have suggested that our radio emissions, which have been leaking into space for over a century, might act as a beacon. Earth would appear as an unusually radioactive planet to any civilization with sufficiently advanced detection equipment, possibly signaling our presence to curious eyes. The next decade promises even more revolutionary discoveries. The Habitable Worlds Observatory, still in early planning stages, would be specifically designed to image Earth-like exoplanets directly and then analyze their atmospheres for clear signs of life. The European Extremely Large Telescope, currently under construction in Chile, will have the resolution to potentially see continents on nearby exoplanets. We might actually be able to map alien worlds, to see their oceans and land masses, and maybe even detect the lights of alien cities if they exist. Think about that possibility for a moment. Within your lifetime, we might not just know that life exists elsewhere. We might be able to see it, to watch alien weather patterns, and to observe seasonal changes on distant worlds, just like we see our own. The 6,000 planets we've discovered so far are truly just the beginning. Conservative estimates suggest our galaxy alone contains at least 100 billion planets. We've examined a tiny fraction, about 0.06% of them. It's like judging all of Earth's biodiversity by looking at a single drop of ocean water. What incredible wonders are still out there, waiting to be discovered? What impossible worlds orbit distant stars? And perhaps most tantalizingly, on how many of them is someone looking back at us, wondering if they are alone? This brings us to a revolution in how we calculate and process information. 2025 will be remembered as the year quantum computing stopped being a distant promise and truly started becoming a reality. The United Nations didn't randomly declare this the International Year of Quantum Science and Technology. They did it because we are at an undeniable inflection point. Just this week, the Nobel Prize in Physics was awarded to 3 quantum computing pioneers, recognizing their foundational work. And if you think that's just academic recognition, think again. The quantum computing market is projected to hit an astounding $450 billion by 2040. Tech giants like Google, IBM, and Microsoft, along with dozens of innovative startups, are now engaged in a race that makes the original space race look leisurely in comparison. Let me paint you a clearer picture of what just happened in quantum computing that has everyone from Wall Street to the Pentagon paying close attention. Scientists at Kyoto University finally cracked a problem that has plagued quantum computing for 25 years. They figured out how to accurately identify and measure something called the W state of quantum entanglement. Now, that might sound like complex technical jargon, but imagine trying to build a classical computer without understanding how electricity flows through circuits. That's essentially what we were trying to do with quantum computers until now. This breakthrough is like suddenly understanding the fundamental language that quantum computers speak, finally giving us a stable foundation to build upon. Quantum computers operate on principles that sound almost like magic, but are actually fundamental properties of the universe itself. While your everyday laptop processes information using bits that can only be either a 0 or a 1, quantum computers use quantum bits, or qubits, that can be 0, 1, or both simultaneously. This remarkable ability is called superposition, and it allows quantum computers to explore millions of possibilities at once. Imagine trying to find one specific grain of sand on an entire beach. A classical computer would have to check each grain one by one, painstakingly. A quantum computer, however, could in essence check all of them simultaneously, dramatically accelerating the search. But here's where 2025 became truly special. IBM just announced that they've achieved error rates below the critical threshold needed for practical quantum computing. For years, the biggest problem with quantum computers was that qubits are incredibly fragile. The slightest vibration, the tiniest temperature change, or even a stray cosmic ray could cause errors, making calculations unreliable. IBM's new system uses something called quantum error correction to fix these mistakes faster than they even occur. It's like trying to write while someone keeps bumping your arm, but now you have an automatic system that corrects the scribbles before they can ruin your work. This is a monumental step toward making quantum computers truly useful. The real-world applications of this technology are already starting to emerge. Goldman Sachs, a major investment bank, is using quantum algorithms to optimize complex trading strategies, potentially saving billions in transaction costs by making more efficient financial decisions. A startup called Quantum Computing, Incos just landed a contract with NASA to use quantum computers to remove sunlight noise from satellite data. This capability could revolutionize our ability to monitor climate change and weather patterns from space, giving us much clearer and more accurate information about our planet. But perhaps most remarkably, researchers at MIT used a quantum computer to successfully simulate a molecule that classical computers have been trying to model accurately for decades. This particular molecule could be key to developing room temperature superconductors, materials that conduct electricity with zero resistance. If achieved, this technology could transform everything from power grids and high-speed trains to medical imaging. Amazon Web Services, a division of Amazon, introduced something called the Ocelot chip, which significantly reduces quantum error correction costs by a staggering 90%. Think about that. In just one breakthrough, they made quantum computing 10 times more affordable and accessible. The Ocelot chip uses something called cat qubits, named after Schrödinger's famous thought experiment. These qubits are naturally more resistant to certain types of errors, acting like a self-correcting spell checker for quantum information. Meanwhile, a company called Rigetti Computing just achieved 99.5% 2-qubit gate fidelity. In simpler terms, that means their quantum computer can perform operations with less than a 0.5% error rate. For comparison, early quantum computers had error rates above 10%. It's like going from a car that breaks down every 10 meters to one that can drive cross-country without a problem. Rigetti is now connecting multiple 9-qubit chips together, building toward machines with over 100 qubits. At that scale, quantum computers will begin to outperform classical computers at certain tasks by margins that are simply incomprehensible, unlocking computational power beyond our current imagination. The implications for artificial intelligence are staggering. Quantum machine learning algorithms can find patterns in vast datasets that would take classical computers millions of years to discover. Imagine an AI that could predict disease outbreaks months in advance, design entirely new materials atom by atom, or solve complex climate models with near-perfect accuracy. We're not quite there yet, but the pathway to these capabilities is becoming increasingly clear. The Quantum Economic Development Consortium just released a report showing that combining quantum computing with AI could revolutionize industries from healthcare to logistics within the next decade, fundamentally changing how we approach problems. But let's talk about the elephant in the room: cryptography. Most of our internet security relies on incredibly complex mathematical problems that would take even the fastest classical supercomputers thousands of years to solve. Quantum computers, however, could potentially crack these codes in mere hours, or even minutes. The race is now on to develop quantum-resistant encryption before quantum computers become powerful enough to break current security standards. The US government are so concerned that they are already transitioning to new encryption standards across all federal agencies. Your bank accounts, your email, your medical records, everything protected by current encryption could potentially be vulnerable to a sufficiently powerful quantum computer. This is where things get particularly interesting from a geopolitical perspective. China has invested an enormous $15 billion in quantum computing research. They even claim to have achieved quantum supremacy with their Zhuangzi X processor, which supposedly performed a calculation in minutes that would take classical supercomputers billions of years. In response, the United States passed new legislation to accelerate its own quantum research and prevent critical quantum technology from being exported to rival nations. We are essentially in a quantum arms race, and the nation that wins could gain an overwhelming technological advantage that reshapes global power dynamics. Private companies are pushing boundaries in unexpected ways. A startup called PsiQuantum is building a quantum computer using photons, particles of light, instead of traditional qubits. Their approach could solve one of quantum computing's biggest challenges: the need for near-absolute zero temperatures. Photons naturally resist decoherence, a process that destroys quantum information, and they can operate perfectly well at room temperature. If successful, this groundbreaking approach could make quantum computers as common as regular computers within a decade, bringing quantum power out of specialized labs and into everyday life. The timeline for practical quantum computing keeps accelerating at a breathtaking pace. In 2015, experts predicted it would take 50 years to achieve truly useful quantum computers. By 2020, that estimate had dramatically dropped to 20 years. Now, in 2025, multiple companies are confidently promising commercial quantum advantage within just 5 years. IBM's roadmap shows systems with over 4,000 qubits by 2027. At that scale, quantum computers could revolutionize drug discovery, finding new medicines in months instead of decades, and potentially curing diseases that have long baffled us. Consider what this means for longevity research, which we'll discuss more later. Quantum computers could simulate the aging process at the molecular level, identifying exactly why cells deteriorate and how to prevent it. They could design specific proteins that repair DNA damage or predict precisely how different genetic modifications would affect lifespan. The intersection of quantum computing and biotechnology might be where we finally crack the code of aging itself, leading to unprecedented extensions of human health and life. The most profound implication might be for our understanding of reality itself. Quantum computers work because quantum mechanics is real, not just a mathematical abstraction. Every successful quantum computation is solid proof that particles really can be in multiple states simultaneously. It proves that entanglement really does allow instant correlation across any distance, defying our classical understanding of space and time. It confirms that the universe operates on principles that defy our everyday intuition. As we build more powerful quantum computers, we're not just creating sophisticated tools, we're directly exploring the fundamental nature of existence. Here's something that keeps many physicists up at night. If quantum computers can simulate any physical system, and if the universe itself operates on quantum principles, then sufficiently powerful quantum computers could potentially simulate entire universes. We could be approaching the technological capability to create simulated realities indistinguishable from our own. And if that's possible, how do we know we're not already living in one? The quantum revolution isn't just about faster computers, it's about answering questions that challenge our deepest understanding of what it means to exist, pushing the boundaries of philosophy and physics. Following the quantum leap, a truly extraordinary event occurred in a French laboratory this February that barely made headlines outside the immediate scientific community. The West Tokamak reactor successfully maintained a plasma at an astounding 50 million degrees Celsius for an incredible 1,237 seconds. That's 22 minutes and 17 seconds of sustained fusion conditions. To put that into astonishing perspective, the core of our own sun is only 15 million degrees Celsius. We created conditions 3 times hotter than the centre of a star and managed to keep them stable for nearly half an hour. If that doesn't give you goosebumps, you might not fully grasp the monumental significance of what just happened. We're no longer talking about some far-off futuristic dream. Private fusion companies are literally betting billions of dollars that they will achieve commercial fusion within this very decade. Commonwealth Fusion Systems, a spin-off from MIT, has raised over $2 billion in funding and confidently plans to put fusion power on the grid by the early 2030s. They are so confident in their technology that they've already signed an agreement with Dominion Energy, a major utility company, to build a prototype power plant in Virginia. This isn't just venture capital speculation. This is a large, established utility company actively preparing for the advent of fusion power. The secret ingredient that changed everything is something called high-temperature superconducting magnets. These revolutionary magnets can create magnetic fields so incredibly powerful they could theoretically lift a car from across a parking lot. Yet, they are made from a ceramic material spray-coated onto steel tape, which is both durable and efficient. Commonwealth Fusion Systems figured out how to precisely wind this tape into coils that can contain 100 million degree plasma, something that seemed utterly impossible just 5 years ago. Their spark reactor, currently under construction, will be the first fusion device designed from the ground up with the explicit goal of producing net energy, meaning it will create more energy than it consumes. But let me tell you about another real game changer that happened this year. Scientists at the University of Texas finally cracked a 70-year-old puzzle concerning particle confinement in fusion reactors. They discovered a way to predict and prevent particle leakage using symmetry theory, a beautiful and elegant mathematical approach, instead of relying on brute force calculations and endless trial and error. It's like finding a secret, direct passage through a complex maze you've been trying to solve for decades. This breakthrough makes designing new fusion reactors at least 10 times faster and could shave years off development timelines, accelerating the arrival of commercial fusion significantly. The competition in the fusion energy race is fierce and global. In Germany, the Wendelstein 7X stellarator just proved it can match the performance of much larger tokamak reactors. A stellarator is a different type of fusion device, looking somewhat like a tokamak twisted into a pretzel. While they are harder to build, they have a key advantage. They can run continuously, rather than in pulses, offering a more stable power output. The German team achieved something called the triple product, a measure of temperature, density and confinement time, that puts them on par with the best tokamaks in the world. They did it with a reactor that looks more like a piece of modern art than a heavy machine, showcasing elegant engineering. Meanwhile, at Lawrence Livermore National Laboratory in the United States, the National Ignition Facility, NIF, keeps breaking its own records. They use a completely different approach to fusion, firing 192 powerful laser beams at a tiny pellet of fusion fuel, compressing it to extreme pressures and temperatures. Last December, they achieved ignition, producing more energy from the fusion reaction than the lasers delivered to the target. They've repeated this monumental feat multiple times now, with one shot producing an incredible 3.15 megajoules of energy from just 2.05 megajoules of laser energy. It's like lighting a match and having it spontaneously turn into a roaring bonfire, a self-sustaining reaction. But here's where things get really interesting and potentially disruptive. A company called Helion is taking a completely different approach to fusion. Instead of trying to contain super-hot plasma in magnetic fields or crush fuel pellets with lasers, they are accelerating 2 plasma rings at each other at an astonishing speed of 1,000,000 miles per hour. When these rings collide, the impact creates fusion conditions for just a fraction of a second, but that's enough. They claim they can harvest the energy directly as electricity, eliminating the need for complex and expensive steam turbines. If this approach works, it could make fusion power plants as simple and scalable as solar farms, fundamentally changing the economics of energy production. The implications of widespread, cheap fusion power go far beyond just providing clean energy. Fusion reactors produce helium-3, an isotope so rare on Earth that it currently costs around $30,000 per litre. Helium-3 could enable a new generation of quantum computers, more advanced medical imaging devices, and even revolutionary fusion rockets for deep space exploration, allowing us to travel across the solar system in a fraction of the time currently required. One single fusion power plant could produce enough helium-3 to supply the entire world's current demand for this precious isotope while simultaneously generating vast amounts of electricity. It's like finding out your car could produce gold as a useful waste product, an astonishing bonus. Private capital is flooding into fusion research at unprecedented rates. Over $7 billion has been invested in fusion startups, with companies like TAE Technologies, General Fusion, and First Light Fusion all confidently claiming they'll achieve commercial fusion before 2035. These aren't wide-eyed dreamers. These are teams that include former SpaceX engineers, Nobel Prize winners, and seasoned veterans from the semiconductor industry. They are applying Silicon Valley's rapid iteration speed and agile development methods to a problem that government labs have been working on for 70 years, bringing a new urgency and innovation to the field. The race for fusion also has geopolitical implications that dwarf even those of quantum computing. China is building an experimental fusion reactor called EAST that recently held plasma for an astonishing 116 seconds, or nearly 17 minutes. They plan to have a demonstration power plant running by 2035. The European Union is constructing ITER, the largest and most complex fusion reactor ever built, although it has been plagued by delays and significant cost overruns. Japan has achieved temperatures of 360 million degrees Celsius in their JT60SA reactor. Every major world power understands that whoever masters fusion first will have essentially unlimited clean energy, granting them a profound strategic and economic advantage on the global stage. Think about what unlimited clean energy truly means for humanity. We could desalinate seawater to irrigate vast deserts, turning arid lands into fertile ones. We could pull carbon dioxide directly from the atmosphere and turn it back into useful fuel, effectively reversing climate change. We could power vertical farms that produce fresh food anywhere on Earth, regardless of climate or soil conditions, ending food scarcity. We could make aluminum and steel without any carbon emissions, decarbonizing heavy industries. Every energy-intensive process that currently relies on fossil fuels could be replaced with clean, abundant fusion power. The entire global economy could be restructured around a foundation of limitless clean energy. The fuel for fusion is almost laughably abundant. Deuterium, a heavy form of hydrogen, can be extracted from ordinary seawater, and there is enough in the oceans to power humanity for billions of years. Tritium, another hydrogen isotope, can be bred from lithium, which is common in the Earth's crust. A fusion power plant the size of a conventional coal plant could power a city of 1 million people, using just a few kilograms of fuel per day. No more mining, no more pipelines, no more massive tanker ships, just water and lithium creating the same energy that powers the stars. This is truly a revolutionary prospect. We're also seeing unexpected breakthroughs in fusion physics that are accelerating progress even further. Researchers at MIT discovered that adding a tiny amount of beryllium to the plasma can increase fusion rates by 50%. It's like finding out that a pinch of salt can make your car engine twice as efficient. A small change with a massive impact. At Princeton, scientists figured out how to use machine learning to predict and prevent disruptions, sudden losses of plasma confinement that can damage reactors. The AI can see subtle patterns in the plasma behavior that human scientists never noticed, allowing it to prevent problems milliseconds before they occur, making reactors safer and more reliable. The timeline for fusion keeps accelerating. In 2010, experts said commercial fusion was 50 years away. In 2015, they said 30 years. Now in 2025, multiple companies are promising demonstration plants within a decade. The UK government is so confident that they're already actively selecting sites for commercial fusion plants, expecting them to be operational by 2040. Canada has even created a specific regulatory framework for fusion power, anticipating its arrival. The infrastructure for a fusion-powered world is being built even before the technology is fully proven. But perhaps the most remarkable thing about fusion is how it could transform our relationship with energy itself. For all of human history, we've been limited by energy scarcity. Wars have been fought over oil, economies have collapsed from energy shocks, and billions of people still lack reliable electricity. fusion could finally end that painful chapter of human history. Energy could become so abundant and cheap that we stop thinking about it as a limited resource and start thinking about it like air or sunlight, an omnipresent, virtually free commodity. Imagine a world where energy poverty is impossible, where we can tackle any problem by simply applying more clean energy to it. That world might be just 15 years away, fundamentally changing the landscape of human civilization. This brings us to the exciting realm of biology and genetics, specifically the progress in CRISPR-based age reversal. In a quiet laboratory at Stanford University last month, something happened that sounds like pure science fiction. Scientists took brain cells from elderly mice, cells that had essentially given up on dividing and regenerating, and somehow turned them young again. These cells weren't just healthier or more active, they were genuinely young, at the molecular level. The treated mice subsequently showed an incredible 30% extension in their lifespan, and their cognitive function returned to levels seen in mice a mere fraction of their age. If this groundbreaking work translates successfully to humans, and early trials suggest it might, we could be looking at adding many healthy decades to the human lifespan. The primary tool making this possible is CRISPR-Cas9, a revolutionary gene editing technology that won the Nobel Prize just a few years ago. However, CRISPR has advanced so rapidly that those early achievements now seem primitive compared to what's possible today. Think of CRISPR as extremely precise molecular scissors that can cut DNA at exactly the right spot, combined with a sophisticated GPS system that guides those scissors to exact genetic addresses within our cells. But what scientists have accomplished in 2025 goes far beyond simple cutting and pasting of genes. They are now using CRISPR to orchestrate a complex symphony of genetic changes that literally reverses the aging process itself, targeting its fundamental mechanisms. The key breakthrough came when researchers identified something called the SLC220AA1 gene, which controls glucose transport specifically in brain cells. As we age, this gene becomes overactive, essentially flooding our neurons with excess sugar and, in simple terms, caramelizing them from the inside. By using CRISPR to carefully dial down the activity of this single gene, scientists were able to restore youthful function to brain cells that were essentially senile. The old neurons began dividing again, forming new connections and creating fresh memories. It's like taking a slow, outdated computer from the 1980s and upgrading it to modern specifications, except we're doing it with living complex tissue. But brain rejuvenation is just the beginning. At Harvard Medical School, the pioneering George Church's lab has identified 25 longevity genes that, when activated properly, can extend the lifespan of mice by up to 50%. They aren't just making mice live longer, they're making them live better. These genetically modified mice maintain remarkable muscle mass, bone density, and immune function well into what should be their twilight years. They are in essence aging at half speed, and Church confidently predicts that this astonishing technology could be ready for human trials within the next 5 years. The approach they are taking is nothing short of revolutionary. Instead of trying to fix the thousands of individual things that go wrong with aging, they are targeting the master switches that control the entire aging process itself. One of these crucial switches involves something called Yamanaka factors, 4 specific genes that can reprogram adult cells back to an embryonic youthful state. The trick, which they are mastering, is to activate these factors just enough to rejuvenate cells without turning them into uncontrolled stem cells or, even worse, causing cancer. It's like rolling back the odometer on a car without having to take it completely apart. Teams at the Salk Institute have demonstrated this partial reprogramming in living animals with stunning results. Mice with progeria, a rare disease that causes accelerated aging, lived 30% longer when treated with periodic doses of Yamanaka factors. But more importantly, their organs showed genuine signs of rejuvenation. Kidneys that were failing started working again, hearts pumped more efficiently, and even their skin became noticeably more elastic. The mice didn't just live longer, they truly became biologically younger. The speed of progress in this field is breathtaking. Just 5 years ago, accurately editing a single gene was considered a major scientific achievement. Now, scientists at UC Berkeley are editing dozens of genes simultaneously, orchestrating complex genetic programs that would have seemed impossible in 2020. They're using new, more advanced variants of CRISPR, like prime editing and base editing, that can change single letters of DNA without even cutting the double helix. It's like going from a blunt sledgehammer to a delicate surgical laser, allowing for incredibly precise and safe genetic modifications. One of the most promising developments involves targeting senescent cells, often referred to as zombie cells, which accumulate in our bodies as we age. These cells have stopped dividing but stubbornly refuse to die, instead secreting inflammatory chemicals that damage surrounding healthy tissue. Researchers at Mayo Clinic have developed CRISPR therapies that specifically target and eliminate these harmful senescent cells. Mice treated with these senolytics showed significantly improved kidney function, increased running endurance, and even regrowth of hair. Human trials are already underway for conditions like osteoarthritis and pulmonary fibrosis, offering hope for treating age-related diseases. The implications for specific diseases are staggering. Alzheimer's, a devastating condition that affects millions worldwide, might become preventable by editing just a handful of genes. Scientists have identified genetic variants that make some people virtually immune to Alzheimer's, and CRISPR could potentially give everyone these protective mutations. Similarly, genes that affect cholesterol metabolism, blood pressure regulation, and chronic inflammation could be edited to prevent heart disease before it even starts. We're talking about not just treating disease, but engineering true immunity to it, fundamentally changing the landscape of human health. Private companies are now racing to commercialize these revolutionary technologies. Altos Labs, backed by billions in funding, has recruited some of the world's top aging researchers to develop advanced cellular reprogramming therapies. Calico, Google's ambitious life extension company, is using artificial intelligence to identify new longevity targets for CRISPR editing, combining the power of AI with genetic engineering. A startup called Rejuvenate Bio is already testing age reversal gene therapies in dogs, with human trials planned for as early as 2027, bringing this science closer to our everyday lives. But perhaps the most intriguing development is the growing discovery that aging itself might not be as inevitable as we once thought. Researchers studying supercentenarians, people who live past 110 years old, found that many carry unique genetic variants that seem to slow or even reverse aspects of aging. One woman in France, Jeanne Calment, reached an astounding 122 years old with the cardiovascular system of someone in their 60s. CRISPR could potentially give everyone these superhuman longevity genes, democratizing extreme longevity. The ethical implications of these breakthroughs are profound and urgent. If we can extend human lifespan by decades or even centuries, who gets access to these treatments? How would society function if people routinely live to 150 or beyond? What happens to fundamental concepts like retirement, inheritance, or even marriage if death becomes a distant prospect rather than an imminent certainty? These are no longer hypothetical questions. They are challenges we urgently need to address within the next decade as the science rapidly progresses. Some researchers are going even further, suggesting that aging itself should be classified as a disease. Dr. David Sinclair at Harvard, a leading figure in longevity research, argues that aging is not a natural, unavoidable process, but a disorder that can be treated and ultimately cured. His lab has shown that the information to be young is still present in old cells. It just needs to be reactivated. Using a combination of CRISPR and chemical compounds, they've successfully restored vision in blind mice and even reversed paralysis in mice with damaged optic nerves, demonstrating the incredible regenerative potential hidden within our own biology. The convergence of CRISPR with other cutting-edge technologies is accelerating everything. Artificial intelligence can now predict how specific genetic changes will affect lifespan with remarkable accuracy, helping scientists choose the most effective interventions. Quantum computers, as mentioned earlier, could simulate the aging process at the molecular level, identifying intervention points we never even knew existed, unlocking entirely new avenues for research. Nanotechnology could deliver CRISPR components directly to specific cells, precisely editing our genomes from the inside out, making the process incredibly efficient and safe. We are approaching what some scientists call longevity escape velocity, the point where we can extend life faster than we age. If we can add more than 1 year of life expectancy for every year that passes, then death theoretically becomes optional rather than inevitable. This might sound like pure fantasy, but consider that human life expectancy has already doubled in the last 200 years. The crucial difference now is that we're not just treating symptoms or preventing disease, we're directly hacking the source code of life itself. The first person to live to 150 might already be alive today. They might even be listening to this right now. The question isn't whether we can defeat aging, it's whether we're truly ready for a world where we have. Because make no mistake, the ability to edit our own genes, to reverse aging at will, and to essentially become different, enhanced versions of ourselves represents a transformation of the human condition as profound as the development of language or the discovery of fire. We're on the verge of taking direct control of our own evolution, and the decisions we make in the next few years will echo through centuries, perhaps even millennia to come. This leads us to an exploration of medicine and neuroscience and the incredible advances in brain-computer interfaces. A paralyzed man in Switzerland just typed a message with his thoughts at an astonishing 90 characters per minute, nearly as fast as many people can text on their phones. Another patient controlled a robotic arm so precisely that she could pick up a coffee cup and drink from it, something she hadn't been able to do with her own arms in 15 years. These aren't feel-good stories from some distant future. They're happening right now in 2025, and they are just the beginning of a revolution that will fundamentally alter what it means to be human and interact with the world. Precision Neuroscience, a company founded by former Neuralink executives, just published groundbreaking results from their first human trials that have the entire neuroscience community buzzing with excitement. Their Layer 7 cortical interface is an incredibly thin film, even thinner than a human hair that sits gently on the surface of the brain. It's capable of reading electrical signals from thousands of neurons simultaneously. Unlike other brain implants that require drilling through the skull, this revolutionary device can be inserted through a tiny slit smaller than a grain of rice. The entire procedure takes less than 20 minutes, and perhaps even more remarkably, the implant can be removed just as easily, offering unprecedented safety and reversibility. What makes this breakthrough so remarkable isn't just the incredible technology itself, it's what the technology has revealed about consciousness. When researchers meticulously analysed the brain signals from these implants, they discovered something that challenges everything we thought we knew about how consciousness works. The brain doesn't simply generate consciousness like a computer generates calculations. Instead, consciousness appears to emerge from the complex interaction between the brain and the body, particularly from something called interoception, our continuous awareness of internal bodily signals such as our heart rate, breathing, and gut feelings. Think about this for a moment. Your fundamental sense of being you, your very consciousness, might not originate solely in your brain at all. New research from the University of Sussex shows that conscious experience begins with how the brain interprets signals from your heart, your gut, your breathing, and even your skin temperature. The brain is constantly predicting what these signals should be, and when reality doesn't match that prediction, consciousness emerges from that mismatch. It's almost as if consciousness is the error correction mechanism of existence itself, constantly updating our internal model of the world and our place within it. This profound discovery is already changing how we approach and treat disorders of consciousness. Patients in vegetative states, who previously showed no behavioral signs of awareness, were connected to these advanced brain-computer interfaces, and something extraordinary happened. Many of them were actually conscious, trapped within bodies that couldn't respond. Using these interfaces, they could answer questions, express preferences, and even communicate with their loved ones for the first time in years. One patient, unresponsive for 7 years, used the interface to tell his family he wasn't in pain and wanted to keep living. Another simply asked to listen to Tool, his favourite band. These stories highlight the immense human impact of this technology. The implications for mental health are equally profound. Conditions like depression, anxiety, and PTSD all involve disrupted patterns of brain activity that we can now observe and potentially correct in real time. Researchers at Johns Hopkins are using brain-computer interfaces to detect the neural signatures of depression before patients even realize they are sliding into an episode. The system can then stimulate specific brain regions to prevent the depression from taking hold. It's like having a pacemaker for your mood, actively regulating your mental state to maintain well-being. But the technology is advancing so rapidly that we're already moving beyond purely medical applications. At the University of California, researchers have created a true brain-to-brain interface that allowed 3 people to play Tetris together using only their thoughts. One person could see the full game screen, while the other 2 could only see the falling blocks. They had to coordinate their thoughts to rotate and place the pieces correctly. They achieved an impressive 85% success rate, proving that we can create a functional telepathic link between human minds, a feat that was once relegated to science fiction. The military applications of this technology are causing both excitement and concern. DARPA, the Pentagon's research arm, is developing neural interfaces that would allow soldiers to control swarms of drones with thought alone, or communicate silently on the battlefield without uttering a single word. Pilots could fly aircraft at the speed of thought, making decisions faster than any enemy could possibly respond. But this raises terrifying questions about the future of warfare. If we can control machines with our minds, can those machines control us back? Could an enemy hack into a soldier's brain interface and turn them against their own forces? The ethical dilemmas are immense. Commercial applications are also arriving faster than anyone expected. Meta, formerly Facebook, is developing non-invasive brain interfaces that can detect the words you're thinking before you even speak them. Imagine texting without touching your phone, or translating your thoughts directly into any language instantly. Apple has patents for brain interfaces that could let you control your entire digital life with thought alone, from opening apps to composing emails. We are rapidly approaching a world where the boundary between mind and machine doesn't just blur, it disappears entirely, leading to a new era of human-computer interaction. The strangest discoveries are coming from studies of anesthesia and psychedelics using these advanced brain interfaces. When patients under anesthesia are monitored, we can literally see consciousness flickering in and out like a candle flame. But here's the weird part. Sometimes, consciousness appears to persist in forms we don't recognize. Patients report vivid experiences during periods when their brains showed no activity in regions we previously thought were essential for consciousness. It's as if consciousness can exist in ways our current science simply can't explain or detect with our existing tools. Psychedelic research is revealing even more profound mysteries. When people take substances like psilocybin or DMT while connected to brain interfaces, their neural activity often becomes more random and more chaotic. Yet they report experiences of profound clarity, deep meaning, and interconnectedness. The default mode network, the brain system associated with our sense of self and ego, essentially dissolves. People report experiencing consciousness without a self, or awareness without an I. These states might show us what consciousness looks like stripped of the ego, the narrative self that we usually mistake for who we are, opening new avenues for understanding subjective experience. The philosophical implications of these findings are staggering. If consciousness truly emerges from brain-body interactions rather than solely from the brain, then artificial intelligence might never be conscious in the same way we are, no matter how intelligent it becomes. But it also means we might be able to create entirely new forms of consciousness by altering these interactions. Some researchers are already experimenting with artificial interoception, giving AI systems simulated bodily signals to see if something resembling consciousness or subjective experience emerges. This pushes the boundaries of what we consider life and awareness. We're also discovering that consciousness might not be a binary on or off state, but rather exist on a spectrum with many degrees and types. Locked-in patients show one type of consciousness, dreamers another, and meditators yet another. Brain interfaces are revealing that even in healthy, awake people, different parts of the brain can have different levels of consciousness simultaneously. Your visual cortex might be highly conscious, while your motor cortex operates unconsciously, all in the same moment. This complex layered nature of awareness is a revolutionary concept. The most controversial research involves enhancing normal human consciousness. Scientists at MIT have shown that precisely targeted electrical stimulation of specific brain regions can temporarily boost IQ by up to 20%, enhance creativity, or even induce savant-like mathematical abilities in ordinary individuals. Professional gamers are already using transcranial direct current stimulation, TDCS, to improve their reaction times and focus. Students are using it to enhance memory formation and retention. We are rapidly approaching a world where cognitive enhancement through brain stimulation could become as common and accepted as drinking coffee, fundamentally changing human potential. Some researchers are going even further, suggesting that brain interfaces could allow us to experience entirely new forms of consciousness senses beyond our biological limitations. Imagine having direct sensory experience of magnetic fields, like birds do, or seeing in infrared, like snakes. We could potentially download skills directly into our brains, Matrix style, or even share memories and experiences directly between individuals, blurring the lines of individual identity. The boundary between self and other, between individual consciousness and collective awareness, might become voluntary rather than fixed, offering unprecedented ways to connect and understand each other. But perhaps the most profound discovery from this field is the growing scientific theory that consciousness itself might be a fundamental feature of the universe, not merely an emergent property of complex brains. This theory, called panpsychism, suggests that everything, from electrons to galaxies, possesses some rudimentary form of experience or awareness. Brain interfaces might not be detecting consciousness so much as tuning into it, like a radio picking up waves that were always there. If this is true, then death might not be the end of consciousness but simply a transformation into a different form of awareness, a continuation of experience in a new state. This perspective completely redefines our place in the cosmos. This exploration naturally leads us to delve into the fascinating and sometimes unsettling world of psychology and behavior, and the mysteries of mind control and memory. Your brain is lying to you right now, not in some metaphorical sense, but literally creating false memories, altering your perception and rewriting your past experiences in real time. Scientists at McGill University just published research showing that gaslighting, the psychological manipulation technique, actually works so effectively because our brains are inherently designed to be reprogrammed by social input. What we generally call reality is really just a consensus hallucination, a shared agreement that can be hacked by anyone who truly understands the code. This shocking discovery came from carefully studying people in controlled gaslighting experiments, where researchers deliberately gave participants false information about events they had just witnessed. Brain scans revealed something truly astonishing. When someone you trust tells you something happened differently than you remember, your brain doesn't just doubt your memory, it actually rewrites it. The hippocampus, the crucial brain region where memories are stored and formed, shows the exact same activation patterns as when forming new memories. Your brain is literally editing your past to match what you are being told by a trusted source. This isn't a bug in human consciousness. It's a feature, an evolutionary adaptation. Our brains evolved to prioritize social cohesion and group harmony over objective truth. For most of human history, being cast out from the group meant certain death. So, when the group says the berries are poisonous, even if you vaguely remember them being safe, your brain quickly updates your memory to match the consensus, ensuring your survival within the group. In 2025, this ancient mechanism is being ruthlessly exploited by sophisticated social media algorithms, political propaganda campaigns, and even advanced marketing strategies that can literally change your memories of products you've used or events you've experienced. But here's where it gets truly weird. Researchers at UC San Francisco discovered that memories aren't just susceptible to social manipulation. They can be completely fabricated using a cutting-edge technique called optogenetics. By stimulating specific neurons with precise flashes of light, scientists can implant entirely false memories in mice. The mice genuinely remember events that never happened, showing the same fear responses and behavioral patterns as if the events were real and traumatic. Human trials are, for obvious ethical reasons, strictly off limits, but the underlying mechanism appears to be identical in human brains, suggesting a terrifying potential for misuse. Even more disturbing, a study released last week showed that high-fat junk food can hijack your memory systems within just 4 days. Scientists fed mice a diet similar to what many Americans consume daily, high in processed fats and sugars, and watched as their hippocampal neurons became hyperactive and disorganized. The mice rapidly lost the ability to form new memories properly and showed clear signs of confusion about recent events. When researchers restored normal glucose levels and a healthy diet, the neurons calmed down and memory function returned. Your diet is literally editing your ability to remember reality accurately, demonstrating the profound link between physical health and cognitive function. The implications for conditions like Alzheimer's are revolutionary. We used to think memory loss in dementia was like files being permanently deleted from a hard drive, but new research suggests the memories are still there, we just can't access them. Scientists at MIT have successfully restored lost memories in mice with Alzheimer's by using light to stimulate specific neural pathways. The memories weren't gone, they were simply disconnected. Human trials using focused ultrasound to achieve similar effects are showing promising early results, offering a glimmer of hope for millions suffering from dementia. But memory is just the beginning of the psychological mysteries we're unraveling. Morning sickness, that miserable experience of pregnancy that affects 70% of pregnant women, turns out to be a sophisticated evolutionary defense system. UCLA researchers discovered it's not random nausea. It's a precisely calibrated biological program that protects the developing fetus from potentially harmful foods. The timing, intensity, and specific triggers of morning sickness all correspond to critical periods of organ development in the fetus. Women who experience moderate morning sickness actually have lower rates of miscarriage and birth defects, indicating its protective role. The mechanism behind this is fascinating. When a woman becomes pregnant, her immune system begins identifying foods that could contain pathogens or toxins harmful to the developing baby. It then triggers nausea specifically for those foods, creating a powerful aversion that can last throughout the pregnancy. It's so sophisticated that it can distinguish between similar foods based on tiny chemical differences. This is evolution programming behavior through physical discomfort, using the mother's body as an incredibly sensitive chemical detection system for the baby's safety. Speaking of evolution shaping behavior, researchers have made a shocking discovery about autism. Rather than being a disorder or a mistake, autism appears to be intrinsically linked to the rapid evolution of uniquely human brain regions. The very same genes that gave humans our distinctive cognitive abilities, our capacity for abstract thought, complex language, and technological innovation are the ones associated with autism. In essence, autism might be the price we pay for the evolutionary advances that truly made us human, a byproduct of our advanced intelligence. Studies of autistic individuals show they often have profoundly enhanced abilities in pattern recognition, systematic thinking, and intense attention to detail. These traits would have been incredibly valuable in early human societies for tasks like tracking animals, identifying edible plants, or meticulously creating complex tools. The prevalence of autism has remained relatively stable throughout human history, suggesting it's not a disease to be eliminated, but a variation that provides unique advantages to the species as a whole. Silicon Valley has an unusually high rate of autism, and that's probably not a coincidence. It's where those cognitive differences are most highly valued and contribute to innovation. The way our brains process social information is also being completely revised. A massive study using advanced brain imaging found that loneliness literally changes the structure of your brain. Lonely people have different patterns of white matter, the neural highways that connect brain regions. Their default mode network, the brain system active when we're not focused on the outside world, is hyperactive, suggesting an overemphasis on internal rumination. They also show increased activity in regions associated with vigilance and threat detection, making them more sensitive to perceived danger. Loneliness doesn't just feel bad, it fundamentally rewires your brain for survival in isolation, altering your perception of the world. But the most unsettling discoveries involve free will, or rather, our apparent lack of it. Neuroscientists can now predict with 80% accuracy whether you'll choose to move your right or left hand up to 10 seconds before you think you've made the decision. The conscious experience of choosing appears to be a post hoc narrative, a story your brain creates after the fact to explain decisions that were already made by unconscious processes. Your brain decides, then you become aware of the decision, and then you create a story about why you decided. Free will might be the ultimate illusion, a comforting narrative our brains construct. This has profound implications for criminal justice, mental health treatment, and personal responsibility. If our decisions are made unconsciously before we are aware of them, can we truly be held responsible for our actions in the traditional sense? Some courts are already considering neuroscientific evidence in sentencing, recognizing that severe brain injuries or abnormalities can eliminate what we normally consider free choice. We're approaching a future where brain scans might be more important than testimony in determining guilt or innocence, fundamentally reshaping our legal system. The manipulation of behavior through environmental cues is reaching scary levels of sophistication. Casinos have long known that certain sounds, lights, and patterns can trigger compulsive gambling behaviors. But new research shows just how precisely behavior can be controlled. By analyzing millions of data points from online behavior, AI systems can now predict with 93% accuracy whether someone will make a purchase, click a link, or even fall into depression. We're not just tracked online, we're actively being programmed by highly intelligent algorithms designed to influence our choices. The scariest part is how subtle this manipulation can be. Researchers found that showing people certain colours for just 30 milliseconds, too fast for conscious perception, can alter their mood and decision-making for hours afterward. The music playing in stores is carefully selected to alter your walking speed and increase purchase likelihood. Even the temperature and humidity in shopping environments are meticulously optimized to put you in a buying mood. Your environment is constantly programming your behavior below the threshold of your awareness, making you an unwitting participant in a grand experiment of influence. But there is hope. Understanding these insidious mechanisms gives us the power to resist them. Meditation has been shown to strengthen the prefrontal cortex, the brain region associated with conscious control and deliberate decision-making. People who meditate regularly are less susceptible to manipulation and show greater activation in brain regions associated with free will, if such a thing truly exists. Knowledge itself becomes a crucial form of protection. Once you know how your brain is being hacked, you can start to build defenses, to reclaim your autonomy, and to make choices based on genuine intent rather than unconscious programming. As we drift through these final moments together, think about what we've witnessed tonight. An interstellar visitor hiding behind our sun that might reshape how we understand our place in the cosmos. 6,000 worlds orbiting distant stars, each one a mystery waiting to be solved. The promise of unlimited clean energy from fusion is finally within our grasp. The astonishing ability to edit our own genetic code, to reverse aging itself, offering a chance at unprecedented longevity. Machines that can read our thoughts and perhaps soon share our consciousness, blurring the lines between human and artificial intelligence. The troubling realization that our memories can be rewritten, our behavior programmed, and our reality subtly manipulated. Unexplained phenomena in our skies that governments can no longer ignore, and a climate system pushed to breaking points we didn't even know existed, demanding urgent action. These aren't separate, disconnected stories. They are all interconnected chapters in the same grand cosmic narrative, the story of a species on the verge of profound transformation. We stand at a critical threshold between what we were and what we might become. The decisions we make in the next few years about how we use CRISPR, how we merge with artificial intelligence, how we respond to climate change, and whether we bravely reach for the stars or retreat into ourselves, these decisions will echo through centuries, perhaps even millennia. Think about where you were listening tonight, perhaps in bed, letting these incredible mysteries wash over you as you drift towards sleep. Maybe on a long drive, watching the stars wheel overhead as you contemplate our tiny place among them. Or possibly just going about your day, but now carrying with you the profound knowledge that we live in the most extraordinary time in human history. A time when the impossible becomes possible, with such regularity that we barely pause to marvel at it. The universe has been patient with us, keeping its deepest secrets for billions of years. But now, in this brief cosmic moment we call the 21st century, those secrets are revealing themselves with breathtaking speed. We are the generation that will witness first contact or definitively confirm we are alone. We'll cure aging, or we'll accept mortality. We'll save our planet, or watch it transform into something unrecognizable. We'll merge with our machines, or we'll maintain our biological heritage. These aren't distant possibilities for future generations. These are critical choices we're making right now. As consciousness itself becomes something we can measure, manipulate, and perhaps even create, we face the deepest question of all. What does it truly mean to be aware in a universe that might itself be aware? Every discovery we've discussed tonight brings us closer to that ultimate mystery. Are we the universe coming to know itself? Are we alone in that knowing? And if we are not, what immense responsibilities come with that profound knowledge? Thank you for joining me on this incredible journey through the frontiers of human knowledge. If these discoveries have sparked your curiosity, stirred your imagination, or even unsettled your comfortable assumptions about reality, please consider sharing this with someone who might appreciate wrestling with these profound questions. Hit that like button if you want to see more deep dives into the science that's reshaping our world, and subscribe with notifications on so you don't miss the next revelation. Because at the pace things are moving, tomorrow's discovery might make everything we discuss tonight seem quaint and outdated. Remember, everything discussed tonight represents our current best understanding based on available evidence and peer-reviewed research. Science is a dynamic process of continuous discovery and revision. What seems certain today might be overturned tomorrow by new evidence. That's not a weakness of science, it's its greatest strength, its relentless pursuit of truth. Stay curious, stay skeptical, and never stop questioning. Until next time, as you drift off to sleep tonight, remember that you're made of star stuff. You're living on a tiny world orbiting an ordinary star in an unremarkable galaxy among trillions, yet somehow, against all odds, you're here. You're aware, and you're an integral part of the greatest story ever told, the universe coming to understand itself through us. Sweet dreams and good night.